So, one way to simplify this is you can multiply, when you're multiplying fractions, you multiply across, multiply bottom. So you could get 36 over, you could get 30 over 36 and simplify. But what you're going to find, it's a lot easier if you can reduce as you go along, meaning 3 goes into 3 one time, 3 goes into 9 three times, 2 goes into 4 twice, and 2 goes into 10 5 times. Now multiply this across, and so you end up with 5 6. Right? Doing this with, kind of with algebra, if we start with our problem as 3x squared over 2 times 2 over 9x, again, you could multiply across, multiply everything on top, multiply everything on the bottom, and then reduce at the end. But you're going to find your life is significantly easier if you can cancel as you go, meaning this 2 can cancel this 2, 3 goes into 9 three times, and this x cancels one of those x's. And so now when I multiply what's left on the top, I've only got a single x on top, and I have a 3 on the bottom, and so everything's simplified at the very end. A little more complicated, so the first two, don't write those down. This one, that's right, this is a little more representative of problems that you'll have to do. So let's have x squared minus x minus 6 over 5x plus 5 times 5 over x minus 3. And what I'd like everybody to do is at least copy this problem down. So, how do we simplify this? Well, whenever you're dealing with fractions, never look at the whole fraction. Look at the top part, look at the bottom. And if I look at the top, I can see I can factor the bottom. And that bottom is going to factor as x minus 3, x plus 2. As far as the bottom, I see there's a 5 in common, so I can factor out a 5, and that's going to give me an x plus 1. There's not much I can do with this, so I'm still going to have 5 over x minus 3. Now, one of the things you want to remember whenever you're dealing with fractions, when you have this is a single term, you want to put that in parentheses. And actually, this division bar, in years past, this has actually been used like a parenthesis. So anytime you see like a bar across something, that means that these things are supposed to be grouped. So now, after everything's factored, you look and you say, well, what can you cancel? And as long as you're multiplying, anything on top can cancel anything on the bottom. So this 5 is going to cancel this 5. This x minus 3 cancels this x minus 3. And when I multiply across, this is going to give me x plus 2 over, and the only thing left on the bottom is x plus 1. All right. So now, let's look at more interesting problems. So let's say I give you x squared minus 9 over x squared minus 2x minus 8 times x minus 4 over x minus 3. And I'll give you